Hi guys, so today I'm going to go over the solution to Palindrome Permutation. That's Chapter 1, Question 4 from Cracking the Coding Interview. So the question is, given a string, write a function to check if it's a permutation of a palindrome. So first thing, we want to define our IOCE, and that is our input-output constraints and edge cases. So they've given us an example here. Given our input, it should output true. So our input is a string, our output is a Boolean value. Constraints, we just want to optimize. And for our edge cases, I'm going to go with empty string. And because we are to ignore spaces, I'll say spaces between the characters and in front and at the end. More than two of the same character, and also both even and odd characters. Okay, so I've written some test cases that utilize all of these edge cases so that we know exactly what our output should be for a given input, and it utilizes these edge cases that I listed out. So I'm going to call our function palperm, and I'm writing this in JAVASCRIPT ES6. So our input is just going to be a string, we'll call it S. So to start things off, we should go ahead and have a plan of action and write some pseudocode. So for this question, we know that a palindrome is a word that is the same forward and backwards, and a permutation is just a rearrangement of a word, like an anagram. So to check if our input string can be rearranged to be the same forwards and backwards, essentially mirrored, then it needs to have an even number of each character, excluding the middle character if it's odd. And in this question, we'll also be ignoring any spaces. So let's see, we know if the string is even, then there must be two of every character. If it's odd, then there must be only one unique character. So for this, we want to be able to keep track of the characters, and we'll use a hash table for that. So we'll use hash tables to store letters. And in JavaScript, it will just be an object. If we see the same letter again, then we'll delete it from the hash table. Then we'll delete from hash. Okay, and then we'll just check the hash table at the end. And if our string is odd, then we should only have one key left in the hash table, and if it's even, then we'll have no keys left. And we'll remember to skip spaces. Great. Okay, so for a hash table in JavaScript, it's just an object, and then we'll have a character count to keep account of all of the non-space characters, so that at the end we'll know if we're looking for an even or an odd palindrome. And then we're just going to loop through our string. So for I equals 0, while I is less than s up length, then s plus plus. Great. So we're gonna call our current character C, and that will be our character at position I. And since we're skipping spaces, then if we see a space, then we'll just go ahead and continue, which basically skips that iteration. Then if that character already exists in our hash, then we'll just delete it. Otherwise, we'll store it in the hash. and we can just store it as true. Okay, and then we'll increment our character count. Great. So then once we've finished our for loop, our hash table will be filled with either 1 or 0 keys if indeed our string can be a palindrome. So then we'll just have to check. So if the character count is even, so char count is evenly divisible by 2, then, so if it's even, then we'll get the number of keys, object dot keys in our hash dot length, and that should be 0 if indeed it is a palindrome. And otherwise, we'll return object dot keys in our hash dot length is equal to 1. So basically, if our character count is even, then our hash table should have no keys, because if there were one, then it's not a palindrome. If our character count is odd, then we're allowing for 1 key, and that would be the middle letter. And there we have it. So we'll return true if it's equal to 0, and we'll return true if it's equal to 1 for odd. And so we can go ahead and test this out with our test cases, and you can see that all of our test cases pass. And so now for time and space complexity. So for time complexity, we're really just iterating through our string once. We're just doing 1 pass, so it's going to be linear. For space complexity, in the very worst case, we have all unique characters, then in our hash table, it's just going to be stored 1 key for every character in our string, so it would also be linear. Okay, great, and there we have it. So if you guys have any questions, corrections, suggestions, or a better solution you want to share, please let me know, and thanks for watching. Bye!